Welcome back to the channel. It's been ages, probably a little bit too long I would imagine. Today I got something different for you. Working on a bike today. So what I'm going to be doing is making a torque arm. Some of you who've subscribed have asked to see some machining, engineering kind of videos. So what I'm going to do is I'm going to try and do like a bit of a time-lapse video of some milling machine work, some lathe work. So I'll talk you through the process of what I'm doing. That is a torque arm for the rear brake caliper of my Fazer. Now, we don't like steel. Steel's too heavy, weighs a ton. No good. We can do better. So this goes there. That's how that goes. It's to stabilise the rear caliper, because when you hit the brakes, the acting force of the brake disc tries to drag the caliper around with the brake disc, so we have torque arms to stabilise them. The idea, and it's not my idea, it's a good mate of mine, an engineering mate of mine gave me the idea of how to do this one, so I can't take credit for the idea. All I can take credit for is the actual machining process. So the idea is that we use these aluminium 1-inch sections, and here in the chuck of the lathe I've got some 3/4-inch round bar. So the idea is that oh, hang on a second, I've also got, hang on a minute, don't go anywhere, these nice little countersunk screws, all stainless steel. So the idea is that these two get machined out with a PCD of the same as that, and then this is going to be drilled out to 5mm. I'm going to run an M6 tap all the way through it. So I've got an M6 thread all the way through it, then I'm going to part them off in sections, and they're going to become spacers to sit between these. In essence, it's going to give me that clearance there, so I'm going to have that gap there like that with those spacers. I'll be drilling all the way through these, through the centre of the spacers, countersinking them and using these nice little screws, countersunking here so it's all nice and flush. So you're going to get to see a bit of lathe work, a bit of milling machine work, and with any luck I don't mess it up, because you don't get too many second chances at this stuff. So yeah, I'm going to cut to some sped up footage. Hope you enjoy the video. Thank you. So I don't know how that first part of the time lapse is going to turn out, but I hope that you got a rough idea of me marking up the centres, and what I've done is I've centre punched 30mm increments down its exact centre. So now you're going to get a video of just me drilling those out. And what I'll do is I'll use the gauge down here to measure up a bang on 30mm, so that the holes are exactly where they need to be. Alright, so let's crack on with this. With any luck, you can see that there. I'm going to dial this into exactly 0. I'm going to 0 this now. And it's probably quite hard to see in the time lapse of me dialing it in to 0, but there we are, that's bang on 0. So we lock the bed, so that takes out any movement. Lock it X and Y. 0.01, so that's no point going the extra mile, we're close enough there. So the coolant for the drill bit is nothing fancy, it's just some WD-40. I'm not turning the drill too quickly because alloy is quite soft stuff, so you don't need to speed it up, otherwise you build up a load of heat. I'm just applying very, very light pressure here. Very light pressure. I should really have something underneath that to support it. But it's alright, we're going to wing it. It'll be alright. It's important when you're drilling alloy, or working with alloy in any way, aluminium, aluminum, as you Americans call it, aluminum. It's important that you keep an eye on your tool binding in the material. Alloy is absolutely, as soft as it is, it's horrible stuff on the cutting pieces. It has a habit of binding up, and you get little rolls of alloy that bind up on the cutting edges and in the flute of the drill bit. So I'm drawing the drill bit back out every now and again just to clear the flutes out. Just like that. I don't know if you can see through this gate, through this perspex. I'm hoping that you can. What if we go over it like that? How's that? Yeah, look, and we're through. Yes, that's the first one. So that was drilled at 0. So what I'll do now is I'll move this along. I don't even have to use my hands, we'll use the power feed for that. I'll stop it at excuse me, I'll stop it at 30mm. Clear that off. We'll stop this at 30 and it'll be bang on top of that centre punch mark. Let's see how close I can stop it at 30. Ready? Half a mil out. Not too bad. Dial this in, perfect it by hand. Don't know if you can see that, I'm hoping that you can see that. Get it at 30. Perfect. I'll lock the bed. That falls on top of the centre punch mark. Okay? And so forth. So that's what we'll be doing now. Again, bit of cutting fluid. All of you precision engineers out there that are watching me are probably mortified at my cowboy tactics. Just so that you know, I am not I'm not trained in this stuff. I'm self-taught. So if anyone's got any advice for me, I'll be happy to listen and learn, because this is a learning process for everyone. Everything that I've learned, I've done through experience. So I learnt not to turn my drills too quickly. I've learnt which is the most suitable coolant for what I do. Like I say, I'm no precision engineer. Right, so there's 30mm perfectly between that one and that one, and there'll be 30mm between that one, the next one, next one. But what I am going to do is I'm only going to make 3 spacers out of this round bar. The other holes will be empty holes, and they'll be purely decorative. So I'll open the other, in between every spacer, I'm going to open the holes out to, I don't know, should we do them? We'll do them at like 12mm. We'll drum up to 12mm. We'll give them a nice countersink. We'll give them like a nice tapered edge. We'll polish it all up when we're done. It'll look perfect. Unlock the bed. We move that on to 60. Or you can be posh. You can 0 that again. Hang on. 0. Oh, why has that just died? 0. There we are. I'll move it up to 30. Speed this thing up a little bit. Can you see that? I'm going to stop it. No, half a mil out again. We'll dial the rest of it in by hand. Bring it down to a perfect 30. There you go. How about that? We lock the bed in there. And again, that falls directly on top of the centre punch mark. There you go. Look at that. Perfect. So, onwards. Such a satisfying process. Not going to moody your head too much now or stop it. I'm just going to go for it so we can get the rest of these drilled out. Stopping it at 60. Oh, look at that. It's not far off. That's not too far off.